Okay, on templates. Templates are really pretty simple. Basically you just have the keyword template, then you have type name and T. Um, and templates don't have to just work with types either. I think we cover that in the next lesson or the next folder anyway. Um, but we have a class cool holder, okay, and they're just defining what the types are going to be. So for this class, all right. And down here, this is we kind of do the same thing, but we separate the functions out of the class, and you can see it uses rather strange code to do it. This free, scope resolution operator get x, would normally not be required. I don't know why they're doing a getter function, returning a. I mean, I don't know whether kind of defining, the return type of a getter function is a reference exactly, but because normally you wouldn't want to do that because that would expose the member variable to. I mean, that's not good encapsulation. Because it's returning x, but it's going to return a reference to x. And this is kind of written wrong here. Um, but yeah, it's going to return a reference to that member variable. That's not a really good thing to do for encapsulation purposes. Um, but notice the template type name being, you know, um, defined here on every instance too. So, and I'm not sure what the scope of these template type names is. So I don't know if it would go like clear to the end of your program, or if it just stops at the next template declaration, or what. I'm not really sure what about the scope of this thing. Um, but at any rate, the point is this is how to declare it when you have the function separated. So I guess maybe it just applies to the next object then, because why should they need to redeclare it? It's basically the same exact thing, right? But when you create an instance of the class, this is what you do. You basically just say like cool holder int. Now this, relates to the first study we did. Um, this one up here. No, not that one. This one here. So this is just showing the basic generic use of the templates. So we're instantiating two objects, and they're both integers here, and then this is a float version of the same object. And this is just demonstrating that fact, and we're creating another instance down here, and this is a pointer, instead of an actual object, and then we're going down here and going through a loop and basically, assigning pointers, a shitload of different objects on the heap, and then we're deleting the motherfuckers. So, I don't know what the point of this really would be, but I mean, the point is that it's certainly showing that you can, assign pointers multiple times, again and again and again and again, another objects, of that template class. So that's how you, declare it. You just pass it in what data type you want, and voila. And then here, this pertains to our second example. Right here, the broken out version. And, so it's really just, I'm free, separate, and that's it. Other than that, well, hey, it's all taken care of. I mean, it's not like you have to declare each function or anything, which, it's just the same way you do it up here. So, if we run this thing, it doesn't really do much. If it ever runs. Okay, so it's pretty much, this is going through that big loop, so that's that first example, which is silly. Man, I hate Windows 10. And just show you the code so you can kind of see what it's doing. At any rate, that's pretty much all I'm going to say about it. But templates, can be handy. If you want to use them, they're really pretty simple. So I'm still not totally sure, how often they be used, and any kind of coding I can conceive of anyway right now. But then again, I've got a long ways to go. So anyway, let's open the next project and take a look at it. This is dummies 4, so we're going to do dummies 5. Okay, let's see what this is. Yeah, it does involve templates, and I think this is showing that templates can be used for things other than just types, I think. So, because they can be used for a lot of different things, but let me have a look at it. Well, actually, it seems to just be, templates again are more versatile than just dealing with data types, though. I mean, because you can replace almost anything. You can have like text in there, like a text string or something with a template reference in it, and because it still has to be known at compile time, so it's, it really is just a shorthand way of saving you some work in programming, but it has nothing to do with runtime. I mean, because this is still defined at compile time, so it's almost like a glorified macro, a preprocessor directive of some kind. That's sort of what it does. So, because it's only relevant really at compile time. So, at runtime it's already set in stone. At any rate, this just involves static variables, and and I'm obviously confused about what it's talking about, but that's the only reason I typed it in, so I'm not going to cover it much. Containing the type you specify in classes. What's the point? Page 589. Hold on. Again, on types, you can, kind of see how it's implemented. We got some integers and floats, and just different types we create. So, we had a charge type, and electricity. Okay, so this is an instance right here. Okay, and this is that static variable specifically. You can see charge is that static variable, and because of that, it's accessible out on static memory. Out static memory. So, we can access it independently of any. There are no instances of that class created yet. That's what was confusing me. But yeah, we're accessing that member directly because it's like almost like a global variable, because it's persistent through the length of the program and its existence. But you can access it even though it's a member of a class. You can still access it directly, even with templates. So it shows you how to access it with templates. So, and then we're printing out its charge value, and then we're finally creating an instance of our electricity class, again using a template for it. But see, like this here and this versus this here, this is creating two instances of that same charge. One of them's an integer and the other's a float. So, it's got both versions out there, but this is where we instantiate, an electricity class, but this, since there's no float version, it won't have access to that variable. And I don't know, since we're accessing it like this, it may, I'm not really sure how that would work, but here we're printing out the charge after instantiating, but again, without a floating point version of our electricity class. a floating point instance, it won't access that floating point, member. So anyway, we can execute that and see what it does. So we look at the code, and the next part has to do with it's a totally different topic. So because this is dealing with the vector object, so I'll go ahead and stop it here.